Okay, so as I mentioned, there are two tests, the dissolved oxygen and alkalinity tests that we do for a DOP stream that require you to be able to read a titrator. So a titrator is this, looks like a syringe, has a little tip that allows you to draw fluid out of a bottle. And we'll see that we have two different ones. There is the tip, there's the body of the titrator, and then there's the plunger, this thing shown in turquoise here. So the first idea is, where do you read from? Okay, so what you're going to do when you start that part of the test is you're going to draw up 200 units of the liquid, and you go all the way to the zero. So we see here that you read from this ring that makes the seal inside the body of the titrator. Not this tip down here that's at 30, but you read from the ring here, shown at 0. So you drop to 0. Okay, this is the first titrator. Now the question is, how many units are each of these little lines on here? Okay, and on this one, it tells you both of the titrators. If you flip them over, it'll show you each subdivision equals what. Here, there are 4. All right, so if you think about it, there are 200 units. There are 5 gradations between each of these, so each one has to equal 4. Okay. So we're going to start from 0, read from here, not from here. Okay, and then you put the fluid from the titrator into the testing tube and say that you put this much in, and you need to know, well, you started at 0, you push down, and the color change happened here. The question is, where did we stop? What is the number that the titrator is reading at? Okay, so we said each subdivision is 4, so it's not 20, 40, 60, it's 80, 84, 88, 92, 94. Okay, that makes sense because if you know 96, so 80, 82, 84, 88, yeah, 92. That's wrong. Which is 4. So 4, 8, 12. Yeah, 16. So yeah, that's 96. So this, in this case, it ended at 96. And if you add 4 more, it gets you to 100. That's just kind of a way to check your work. Right, so the answer here would be 96. Okay, another example. Start at 0, push the fluid in, wait for a color change, and it stops here. What would your answer be? Let's take a look. It's past 0, it's past 20, it's past 40, it's greater than 60. It goes from 60 to 64 to 68. Okay, so the answer would be 68. I'm not going to stop, I'm going to check my work. 68, 72, 76, 80. Yeah, so that does check out at 68. Okay, so example 2, the answer would be 68. Third example here. What will the answer be? See the ring? We're not reading from here at 44. We're reading back here at this ring, the front edge of it ends at this gradation, at this little hash mark. How many of those were used? We got 1, 2, 3, 4, 8, 12. 12 would be the answer. Check your work. 12 plus 4, 16, 16 plus 4, 20. So that does check out. So that's the first titrator. And that is the one we use for the alkalinity. The other titrator, number 2, is the one we use for dissolved oxygen. Okay, same exact setup, except we have a different number of units. Instead of 200, we have 10. So that tells us that each of these little hash marks has to be smaller. Flip it over, each one equals 0.2. Okay, so that if you go, right, we have 0.2, 0.4, 0.6, 0. Push it into the solution. Ends here. What is our answer? We said this is 5.0 plus 1 line 5.2. Okay. And I'm always in favor of checking to make sure that you just didn't make a sloppy mistake. If that's 5.2, this is 5.4, this is 5.6, 5.86. Yep, 5.2. Example 2, 0, 0.2, 0.4, 0.6, 0.1. 0.6 is the answer. Second example, titrator 2. And by this point, this one should be a piece of cake. You're an expert now, knowing what you read from here, from here, knowing that these gradations are each subdivision is 0.2. So we go 1 past 2 to 2.2 is the answer for example 3. So, on the quiz, make sure you know which titrator you're using, how much each subdivision is, count your subdivisions, check your work. You're going to do awesome. Fantastic.